Good evening, one and all. In this session, let us learn about preprocessor directives and files, your third unit. Okay, so let me give a brief introduction how the source code is converted into the executable file. If I am writing a program for the addition, I will be giving add.c. You will call this as your source code. Okay, so here your source code is given to the compiler for error checking, right? Syntax error checking, right? So therefore after this it will be given to the linker to execute and generate a .exe file, right? So these are the basic steps involved when a source code is convert.c file. Your source code will be with the extension add.c, right? So this source file is converted into the exe file. These are the basic steps involved. So now what is our preprocessor, right? So preprocessor, before compilation a preprocessor takes place, preprocessor tool takes place to convert your source code to an extendable source code, right? So your source code is with the .c extension. Okay, expanding the source code, right? Your source code is converted to the expandable source code format. Okay, so let us quickly see the brief diagram related to this. Okay, so before that I can say a preprocessor is just a substitution tool. Before the compilation takes place, a preprocessor substitution tool takes place, okay, and instructs the compiler to do the required pre-processing before the actual compilation takes place. So we will refer to the C preprocessor as we will refer it as C preprocessor, CPP. Okay, so this is the rough diagram I'm just showing. Okay, this is your source code having the extra like a file name pri.c. It is given to the preprocessor, like preprocessor tool takes place, forming an expanded source code. I will show you later how this expanded source code will be. Like I can relate you with the example. You can easily say, if you are writing algorithm and a pseudocode, right? A detailed description is a pseudocode, right? So likewise, our source code is given to the preprocessor, generating an expanded source code. Okay, so how it will looks like I will be showing later. And now this expanded source code pri.i is given to the compiler, and there from there it is given to the assembler, and from the assembler we will be it will be given to the linker, and then an executable file is generated, okay, with the same source file name, right? So this is the brief diagram how the stages from source code to executable source code. Okay, so now let us see what are all the different preprocessor directives available. So first one is macro expansion, right? So the mm, second one is it is file inclusion, and the third one is conditional compilation, and the fourth one is NIOUS, miscellaneous directives, right? So the first one is macro expansion, second one is file inclusion, third one is conditional compilation, and the fourth one is miscellaneous directives. Now let me explain these things in detail. So what is macro expansion? Like if you are defining hash, define some global variable like pi 3.141. Okay, so if you want to declare a global variable, so you will be writing hash define above your main program. Okay, so let me give an example here in detail. Okay, so we are discussing about the first preprocessor directive, that is macro expansion. In that we are having the preprocessor directive hash define. Okay, so for defining a preprocessor directive we will be using the symbol hash. Now I will show you a small program. So before we are writing hash include, this is also one of the preprocessor directive which is discussed in detail later. Include stdio.h. Okay, so now we want to use a value of pi many times in my program, and throughout the program I'm writing a massive program. That means I'm writing a large program, so I want to use my pi. So in between files also I have to use my pi value. In between the functions also I have to use my pi value. So I have declared something like globally, I can say globally I have declared. So here I will just declare here with the help of a define preprocessor directive. Okay, by here later on I will write my main function, right? So here I'm just declaring a variable I. Okay, and I'm just I equals to pi star pi, and I'm displaying the value of I. Right, simple, just I'm multiplying. And just when you write the massive programs you can use many times, but I'm just showing the simple program written 0. Right, so now what happens, this pi. Okay, first before compilation it checks for the preprocessor directives. Yes, it has found out the stdio.h file. This will be added for sure. But now we are discussing about the macro expansions part. So in the macro expansions part I am having the hash define. So what happens when it encounters this hash define and you have defined the value? So this guy is defining some value. So before compilation, I said source code, expandable source code will be generated. So every pi, wherever it encounters the pi, it is replaced by the value given by the pi. Okay, so is it you have to include or else you have to define the constants like universal constants? No, I'm just going to define some, I can say number 25. Okay, so I will be using this number here, number equals to some number into number, right? So I will be giving like this. So what happens, my number, or else we can give like this, I equals to numbers. Without getting more confused, I am just simply given like this. I equals to, what is the my number declared? I have given the constant value for the number. What is the constant value? It is 25. So I'll just give 25 into 25. So if it at the time before the compilation, every number will be replaced by its value. Okay, and this structure will be given to the compiler for the error checking. So this structure is nothing but the expandable source code, extended source code. This is the extended source code. Wherever it sees these constants values, it just replaces all the variables with that values, generating an extendable source code file, right? So now this is the our first macro expansion, hash define. Fine. Now let us see the file inclusion. So the second preprocessor directive, second type of preprocessor directive is file inclusion. By the name itself, you can say you are including some files. So hope you guessed. Hash include stdio.h. So when we want to use some header files, we will be giving the include preprocessor directive. Okay, so include is the one of the preprocessor directive as a part of file inclusion. Okay, so either way, some compilers accept this type of include also. I'll just give another file, header file. So some of the compilers, they will allow this form of mentioning including the file also. Okay, so here the first preprocessor directive is the macro expansion, where the macro expansion is nothing but define, and the second one is, we will be seeing the second one, file inclusion, nothing but adding the files that we are using. And the third one is conditional compilation. The conditional compilation process directives are if def and hash and if, right? So this is one of the conditional compilation preprocessor directive. Okay, if defined, okay, execute this set of statements, execute this set of statements here, execute this set of statements if defined over there. Okay, you execute this set of statements. Okay, and here the end if, something like you can say simply it is like if statement. Okay, if defined, execute this set of statements. Or if not defined, and that means if the user has defined some statement, some condition, some scenario, you just execute this set of statements, else don't execute. Okay, so the next one is hash. In this conditional compilation, we are having if def is 1. Okay, and the second one is hash if some test like less than 5, less than 7, whatever it is, hash if. Okay, so I can say it is simply else if. Okay, so here if this condition is true, okay, if this condition is true, you just execute the set of statements over here. Okay, else you just go with the else if part. Okay, so this is the third preprocessor type of preprocessor directives: hash if def and hash end if, and hash if and hash else if. Okay, so the next preprocessor is, I can say those are miscellaneous directives. Okay, so like in when you are writing the massive programs, what we will do, we will be declaring something. I have defined the pi over there, right? So now I have given the pi number, like def hash define, we will go with the number 25. Now in later on the scenarios, in some part of the code I just don't want to or else now I'm just not willing to use this number 25 anymore. So what I will do, I'll just hash undef number 25. Okay, so I will give like this. So if you are giving like this, that will not be going to execute or substitute anymore. Okay, so hash undef, that means undefined. Okay, nothing but whatever you have defined, you just undef here. That is nothing but the miscellaneous directives, one of the miscellaneous directives. And pragma, pragma is the another miscellaneous directive. That is, if we want to skip a part of code, we will be notifying with the Pragma preprocessor directive. Okay, that's all with our preprocessor directives. And let us quickly jump into the files. Let us quickly jump into the files. So what are files, how they are used? Files. So for what purpose we are using the files? Files are nothing but to store massive amounts of data. We will be using files. Not only for storing, we are having massive amounts of data. To access the data manually is a little bit difficult. It is highly impossible scenario. So to access the data in the text files or else binary files, we will be by using some file handling functions, we will be accessing the files even. Okay, let us just quickly see the uses, all those things here. So here, when a program is terminated, the entire data is lost. Here I can say you the definition or else the usage like this. When a program is terminated, the entire data is lost. Storing it in a file will preserve your data even if the program terminates. Okay, after terminate, like if the program suddenly terminates also, if you write them on the files, you are not at all going to lose the data at any case. Okay, so if you have larger amounts of data, it will take time to enter all of them. However, if you have file containing all the data, you can easily access the contents using some file commands. So with using some file commands, you can access the data easily. You can easily, even if you can easily move the data from one computer to another without any changes. So that is the necessities or else uses of files. So now what are the two different types of files? Let us quickly see. So those are text files. By the name itself, you can say they will be with the .txt extension. And the normal notepad text editors like notepad you will be using and writing those files, right? And the other one is binary files. By the name binary itself, it is the combination of zeros and ones. So we will be using saving on .ban with the .ban extension. And next, these are in the zeros and ones format, and these zeros and ones format, it is highly secured when compared to the text files. Okay, so what are the different file operations? We can see creating a new file, opening a file, closing a file, reading and writing information to a file. So with when you want to use a file, okay, you will be declaring file pointer. Okay, by using the pointers, file pointer, you will be accessing. You have, when you want to access the file, you must declare a pointer, a file pointer variable. Okay, so here, when you are working with files, you need to declare a pointer of type. This declaration is needed for communication between the file and the program. So now you are giving a file operations or file functions in your program, and you want to access the files somewhere else, right? So here, this is your C program, okay, and you are writing, let us suppose this is the notepad, right? This is your C program. So in the C program, you will be writing some file functions like fwrite. So you want to write in the notepad. So you are accessing your notepad, or you are some writing some content on the notepad. That means this txt file, text file from your program itself. Okay, that is what here. When you want, when working with files, you need to declare a file pointer. This declaration is needed for communication between the file and the program. Okay, So here we have declared a file star FPTR. FPTR is nothing but file pointer type. Okay, so here this is the syntax for opening a file. PTR equals to F open of file open comma mode. So here this is nothing but to open a particular file we will be using. Okay, so here the important thing, this is the syntax for opening a file, F open. So here I'll be giving the example F open, the name of the file, some a.txt, and here the mode. So what is this mode here? Okay, so here there will be different types of, like when you want to open a file, in which mode, either in the read mode, either in the write mode, or in the some read plus mode, all those things matters. See here, I have just opened this file. Now this was opened in a read mode. I can't edit here. I'm not able to type anything over here. So this file is open. So just for example, I'm just saying the in the read mode means just for the related scenario, I'm just telling. So you can't write here. If you only, if and only if you give enable editing only, it will be opened in the writing mode, right? So unless if you click this button, it will be in the read mode only. Okay, so in some scenarios we will be asking the file to be either open in the write mode or read mode or append mode or read write mode. So many types of modes are there. Let us see from here. Okay, so here I'll be just showing you a table, the read mode, R in the sense read mode. So where you will be giving this R, here you have to give in which mode you have to open a file, whether it is in the, if you want to write, you will be giving W. If you want to read, you will be giving R. If you want to append, you will be giving A. Okay, appending means some joining. Okay, so here these are the different modes available. That is R open for reading. If doesn't exist, F open returns null. So in the read mode, if the file is not existing, that means already file is not there. So what happens? It just returns the null value. Okay, so we will be opening in the read mode and the like text for the text files and the binary files also. Here we have given opening in the binary mode. Next, W for write mode. Okay, if the file exists, its contents are overwritten. Already if the file is existing means the contents are overwritten. That means I'm having already contents in the file. Now I'm opening it in the write mode. That means the already existing contents are erased and the new contents which I'm writing are overwritten. Okay, and this is WB for in the binary mode. We will be usually writing to the text files itself. We are not at all going to write in the WB modes, all those things we are not learning. We are just learning to how to write to the text files itself. Okay, so A for the append. Okay, so appending means joining, concatenating, that means adding. So where the data is added, the data is added at the end of the file. Suppose this is my text file, right? So this is the text file. If I open in the append mode, I have appended the word Rekha. So this is going to append at the end of the file. If I open it in the append mode and the word, the string I want to append is Rekha, so it is going to append at the end of the file. Okay, so next it is R plus mode. If I give here the mode R plus mode, so it is going to open both in the for reading and writing. If the file does not exist means it returns null again. And W plus is also for opening open for reading and writing. If the file exists, the contents are overwritten, which is same like in the W mode. If the file does not exist, it will be created in the W plus mode. Okay. So next we will be having the A plus mode for both reading and writing. So now what is the difference between A and A plus means if the file does not exist, it will be created and then appended. Okay. So once the file is opened means in the while by f open we are opening a file. Okay, we have opened a file, we have accessed the contents, we have written the contents onto the file, and now once the file is opened, must and should you have to close the file. So with f close you will be closing the particular file. So here fclose fptr. So the particular file will be closed after performing a series of actions or the particular actions given by the user. The fclose function which closes the particular file. Okay, so for reading and writing text files, we will use fprintf and fscanf. So fprintf, like we have to write onto the file. Now, right, I'll just opening my file. Here I have opened my file. Now I have to write onto the notepad from my program, right? I am writing in the C editor, right? So from the C editor, I have to write onto my notepad. So I have to write the contents. For writing the contents, what I will be using? Fwrite, okay, sorry, fprintf, fscanf for reading. Okay, so same like your printf and scanf, printing for displaying onto the output screen, and scanf for reading the data from the user. Something like same like your fprintf and fscanf. They are just file versions of printf and scanf. The only difference is expects a pointer to the structure file. That means as like your printf and scanf functions, they are going to write fprintf and fscanf, they are going to write onto your notepad. This is a small program that shows how to write onto the output screen. See here, he has opened the file in the write mode. Okay, and here he is just with the fprintf, he is writing the number. Just if possible, I'll just quickly execute this sort of example for simple thing, the online compiler. Let us, I'm just deleting. Okay, I'm just pasting out over the program here. I'm running the program. Here the program is to take the number from the user, some number, any number, read that number and write the number onto the notepad. See how it runs. Now here at the bottom of the screen, it is asking me to enter the number. For suppose if I write 500, okay, and press and enter. See here, it is the our main program, and here this is the txt file, writing the 500 onto the txt file. And now, yeah, these are some examples of reading from a text file, reading to a binary file. Yeah, and the other function is fseek. Okay, so this is the syntax of fseek. Initially, like to know the particular position in a file. Right now I am writing in the file, I just want to know the position of a particular like cursor or else any particular thing. I just want to know the position, or else from that position I have to write. Even I can say from this position I have to write my things. So with the help of fseek function, I can write at the desired position. If you have many records inside a file and need to access a record, a specific position in a particular file, you need to go to the loop through all the functions. So if I want to go to the file and write to the file at that particular position, I will be using fseek. So fseek file stream offset, and when offset is the position where you have to give. Okay, so this is the about fseek. So here offset, in the place of like offset, you will be giving the seek set. So you have to write from the beginning of the file. This is my notepad. uh, like from the beginning of the file you have to write. This is the beginning, right? So from the beginning of the file you have to write the contents, means you will be giving the seek and seek underscore set. Okay, so here again at the end of the file, this is the end of the file. At the end of the file you want to write, means you will be writing seek underscore end. Okay, and cursor at a particular position, or else the current location of the cursor, if you want to know, it is seek underscore cursor. And the next one is, yeah, I'll be just going checking. Okay, fine. These are all some of the file operations in your C. Those are F write. You can go with F open, F close, file close, file close, file write, sorry, file seek. These are some of the file handling functions in your C. Thank you all.